let's erase our work here. Alright. If we add 30 milliliters of the base, okay, our last step in the titration. So the other ones are exactly the same. What you're going to have in each case is a buffer that you will solve the pH using Henderson-Hasselbalch. The last point's a little bit different though. We've added 30 milliliters of the base. What it turns out we've done is we've actually added a greater number of moles of the base than we have the acid. Okay, 30 milliliters addition of the sodium hydroxide, again it is 0.185 molar. This corresponds to an addition of, it's on here somewhere, 0.0055 moles of hydroxide ion. Okay, so that's how much hydroxide we've added there. Now you'll see this number of moles actually exceeds the amount of acid that we have. And so the acid, to the extent that we have it, is going to totally react with the hydroxide ions. So the change here is going to be minus 0.005 moles. And then at the end we're going to have 0. As this is consumed, we're also going to produce the base over here, okay, the aniline. Okay, we're going to produce 0.005 moles of the aniline. But we're also going to have left over some of the excess sodium hydroxide that was added. The change here is going to be negative 0.005 moles. And then at the end, we're going to have 0.0005 moles of this left. Okay? So in this case, this is kind of a different situation. We no longer have a buffer. What's going to control the pH here is going to be whatever is the strongest base. We have two bases. We have the aniline, which is B, and we have the hydroxide, which is the OH minus. Of the two, hydroxide is by far the stronger base. It's so much stronger, actually, that we can totally ignore the contribution or the effect on the pH of the aniline. So this doesn't really matter. All we're going to focus on is this right here. Okay? So we know how many moles of hydroxide we have. If we can calculate the concentration of the hydroxide, from there it's fairly elementary to find the pH. Okay? So to do that, we're going to take the number of moles, which is 0.005 moles, 0.005 moles, okay, and divide it by the total volume of the solution. Well, this is after the addition of 30 milliliters of the sodium hydroxide solution. We started with 50 milliliters of the acid solution. So the total volume, 30 plus 50 is 80. Put that into liters, it's going to be 0.080 liters, okay? And we calculate the concentration, therefore, it is going to be, it's not written down. Okay, let's calculate. Where's my calculator? Uh-oh, okay. Andrew Lee, give me your calculator real quick. Okay. Let's calculate. We're going to take 0.0005 divided by 0.080. Okay, and the concentration is going to be 0.00625 molar. Okay, from here we can find that the pOH of the solution is going to be whatever it was, I think it's 2.26, and the pH is going to be 11.84. So at the end of the titration, guys, it goes way after we've added excess base, it becomes very basic because we've totally destroyed the capacity of the solution to act as a buffer. The very last thing it's going to ask you to do after you've done all this stuff is you're going to draw a titration curve. Okay, like we showed you guys in class, you're going to have the pH on the y-axis. Here's milliliters of titrants. Okay, right here. And you're going to see that as a shape, something like that as you plot your points. I'm confident you guys can make the graph. So I am Mr. Harper. Thank you for tuning into AP Chemistry.
Woo! Wait,